Hello and welcome back to Gaffy's Grinds. My name is Mr. Gaffy. I'm a science teacher trying to help you understand some more of junior cert science. In these videos, I will be taking different concepts in junior cert science, breaking them down, trying to help you understand them a bit better, and then giving you some practice to do. This is video number 2 in our particles module. Okay, so it's a chance for you to catch up and revise. I do advise, if you haven't already watched the video number 1, particles video number 1, to go and watch that first. This will make more sense then. So this video is going to be about the properties of solids, liquids, and gases. So tips for watching the videos. It's really important to turn off your phone or put it on silent or put it in a different room, and to close any other tabs that you have open on your computer if you're watching this on your computer. The reason for this is you can get distracted very easily and then you're not going to learn as much. So give it your full focus now and put away phones and other tabs. Most importantly, when I ask you to do questions, I ask you to do tasks in the video, it's really important that you do them. If you don't do them, then you're wasting your time watching these videos. You're not going to learn as much. If you do them, I promise you, you will experience much more success in your science exam. In the previous video, we learned how to draw a solid. We drew it like this. We had the particles that were arranged with a regular pattern or a regular arrangement, which meant they had a repeating pattern like this. So they have 4 in a line, then 4 in a line, then 4 in a line, and so on. Now there might be more than 4, there might be less than 4, but they have a repeating pattern, so like this. Now, the properties of the solid are, the first one is that it cannot flow. A solid cannot flow. This is one of the properties of a solid. A property really talks about a property of solids. A property, the word property really just means like a feature. It's how they are, how they behave, how you can describe them. This is stuff that you can see and sense and you can figure out or you can measure. So stuff like the atoms are tightly bound together or tightly stuck together or held together by tight forces of attraction. You can never see that because the particles are too small. So we don't talk about forces of attraction as being a property because we cannot see them. But we can see if you have a lump of iron that it can't flow. So that's something we can see so we can describe the property. We can use then our knowledge of how the particles are arranged to help us describe why the particles cannot flow. Well, the particles in a solid cannot flow because they are held together by tight forces of attraction. A second property is that solids cannot be compressed. They cannot be compressed. Now, what does compression mean? Well, if we were to take over here, the side, if we were to take a box, and in that box, we were to put 5 particles. Now, if we were to take that box and squash it, squeeze the box, then we would have 5 particles in a box, which is much smaller. This, we say, is compression, so squeezing the particles into a smaller space. Now, the particles themselves don't get squeezed, just the space. So all this space that was between, all that space there has got squeezed. We call this compressing. Now, because solid particles are already close together, like this, already close together, there's no way we can squeeze them any closer. There is no space in between them to squeeze. Here there was lots of space. This would be gas particles. There's lots of space in between them. We can squeeze the space. We can push the atoms closer together. Here we cannot push the particles closer together because they are already touching. Solids have a fixed shape. Fixed shape. So a lump, a block of iron, or a block of wood, these solids, they stay as blocks of wood. The shape is fixed, and it's because the particles we know aren't moving anywhere. They're just vibrating on the spot. They don't change their position. So they have a fixed shape. Now, because they cannot be compressed and they have a fixed shape, we say that they do not take the shape of whatever container we put them in. So if you put a block of ice into a beaker, it stays a block of ice. It still stays together in a block like that. Okay, it does not fall down and fill the container. Now, when the ice melts and turns into a liquid, it will do that. But while it's a solid ice block, it stays the shape of the solid ice block. We say cannot take the shape of the container. The shape of the container. Now, all of these are examples of properties. Why are they examples of properties? They're examples of properties because they are things we can see and the ways we can describe a solid with our eyes. We cannot see anything to do with how the particles are arranged, so that is not a property. We use that stuff, how the particles are arranged, to explain the properties, but we can't see them, so they themselves are not properties. Now, it's time for you guys to do some practice now. Okay, so here's 5 questions for you. So what I want you to do is I want you to pause the video and try those questions for me now. Okay, and now you should only be watching the video if you've tried all the questions. A reminder that if you do not do the questions, you are not going to learn as much. You might not learn anything. So it's really important that you do the questions. Okay. All right, so I'm going to show you the answers now. Okay, so it's really important now that you make your corrections. So pause the video, make your corrections now. Okay, the most difficult one there was number 5. It was to do with a syringe. So we have a syringe and it's filled with chalk powder, which is a solid. It said the diagram on the right shows a syringe with a solid inside. A student tries to push the piston down and compress the solid. Explain what would happen. Well, hopefully you figured out that because it's a solid, it cannot be compressed. Therefore, the piston will not be able to push down, so it will not go anywhere. So they will not be able to push the syringe because solids cannot be compressed. I'm hoping that the rest was pretty easy. Maybe number 3, the student says that particles in a solid do not move. Explain why the student is wrong. Well, we know that they do move, but they just move back and forward or up and down on the spot. They don't actually change their position. They don't swap with each other. So the student is wrong because the particles in a solid can vibrate, but they do not change position. All right, well done. Have you got those right? Okay, we're now going to look at properties of a liquid. Properties of a liquid. Now, what I would like you to do is pause the video and draw, like I did in the first diagram. I want you to draw a particle diagram of a liquid. Pause the video. Okay, and I hope you did something like this. So we had our particles and they are randomly arranged. So they're not in rows. They do not have a predictable repeating pattern, but they are close and many of them are touching. Okay, this is a liquid. Now, because the particles are not fixed in position, they can vibrate and they can swap positions with each other. We say that they actually can float. So if we pour them, they can all float in the same, they can all start to move in the same direction. So if you take your glass of water and you tip it over and pour it out, we know the water can float. So this is where all the particles start to move in the same direction. So they can float. The spaces in between them are already quite small. They are already very close together. Some of them are already touching. So I want you to tell me now, can they be compressed or can they not be compressed? So put that in a box here now for me. I'm hoping you said that they cannot be compressed. Why can they not be compressed? They cannot be compressed because there is no space between the particles. Okay, now, if we were to look at a container, say we have a bowl of water, like this. We have a bowl. And in the bowl, we're going to put some water. So we've got the particles, like this. We've got these water particles, and they're close. Many of them are touching. and they form a pretty straight line along the top, like water does, like that. Okay, now we say that the water or the liquid particles, they take the shape of the container. So just like this bowl here, the shape of the bowl is round at the bottom, they take the shape of the bowl. So liquids, the property of them is they take the shape of the container. What would it look like if I took this and put it into a container like a graduated cylinder? So a much smaller, narrower container. How would it be different? Well, it would be different because the particles would now, the same particles that were there before would now have this shape dependent on the container. Okay, so we take them particles, pour it in here, then they would take the shape of this container. Now, say we took, I'm going to get rid of that, say we took a wooden block, which is a solid, and we put the wooden block in to the liquid. This is a wooden block. Well, how could we prove that the particles can flow? Well, what would happen is particles here, that this would obviously sit on top, and the particles would start to flow around the wooden block. So they would come up the sides and the wooden block would sit resting on the top of the water. So they would flow from here up to here along the sides, and the wooden block would be about level with the water. So we say this proves to us that the particles can flow. Okay, it's time now for you guys to do some practice. Sorry about that. The video kind of froze on me there for a minute. So these are the practice questions, questions 1 and 2. Complete them now. Pause the video and complete them, please. Okay, so you should be watching the video if you've tried to complete questions 1 and 2. So explain why solids can flow but liquids cannot. Solids can flow because the force of attraction between the particles is too strong. So solids cannot flow because the force of attraction is too strong. Liquids can flow because the force of attraction is weaker than solids and the particles are able to move. So that helps us to explain why particles can flow and liquids can flow. So flowing is a property of liquids. It doesn't happen for solids. The second question, the student says that liquids can be compressed because the particles can be made smaller. Explain why the student is wrong. Okay. The student is wrong because the particles cannot be made smaller, only the spaces between them can. Liquids cannot be compressed because there are no spaces between the particles. All right, so that's what you should have. Well done, you got those correct. Okay, last of all, we're going to look at the properties of gases. Properties of gases. Now, pause the video and draw a particle diagram of a gas for me. Okay, hope you did this. 1, 2, 3, 4, 5. That'll do. 5 gas particles. Now, first of all, I hope you noticed that this is the first time we've seen the particles really spread out with lots of space. So because they have lots of space, this means that we could squash the space, and this means that gases can be compressed. So a property of gases is that we can compress them. We can squeeze the space. We can squeeze these particles, make them go closer together. And this is because there's the particles have lots of space between them. Now note the important distinction. Space between particles is not a property because we can't see space between particles, but we can see gases being compressed. We can take gases in a syringe, for example, this guy here. Here I have a syringe, okay? And in the syringe now, at the moment, is air. So I'm going to suck in, and there's air in the syringe. And I can put my finger over the end so that no air can escape. And watch what happens. If I push the syringe down, I can squash the air into a smaller space. I can squeeze. So all the air is still there, didn't escape, but I can squash it. Now look what happens if I let go. It pushes the piston back out, and then I can squeeze it again. So that is compressing. Now what am I doing here? I'm squashing all these spaces. I'm not squashing the particles. The particles don't get squashed and made smaller, just the space does. Okay, so that can be compressed. Now, space between particles is not a property. We can't see that, but we can see gases being compressed. So that is a property. Gases will always fill the container they're in completely. Fill the container completely. So they will spread all around the container. And this is because they can flow very quickly. They can flow. Okay, so they fill the container completely, they spread out, and they take up all the space that you let them have. Okay. So we're going to do some practice now. Pause the video now to complete the questions. Okay, welcome back again. You should only be watching the video if you have tried to do all the questions. Okay, so samples of gas can be squashed into small containers. Which word describes this process? Hoping there that you said, I'm hoping that you said compressing or compressed. They can be compressing, compressed. So complete the sentences then. In gases, the forces between particles have what type of strength? Hoping you said low strength, leading to a structure which has large gaps between particles. Therefore, gases have the property that they can be. So if they have large gaps, what does this mean? It means they can be compressed. So check your answers. So they have low strength, big gaps or large gaps, and they can be compressed. Finally, a student draws the particles of a gas filling only one corner of a container. Explain why this is wrong. Well, we know that this is wrong because all the particles will not collect in one corner like this. They will spread out and fill the whole container. So the student is wrong because the particles in a gas spread out to fill the whole container. Okay, I want you to pause the video now and complete the paragraph by filling in the key words. They will appear in yellow in a second, but I want you to try practice them first yourself. Do that now, pause the video. And these are the answers. Really well done if you got those correct. If you didn't, it's not that big of a deal. Just make sure that you fix them now. So just put a red pen through it and put the right one in. Okay, very good. And lastly, pause the video to complete these final questions. Okay, you should be watching the video now if you have completed those 11 questions. And the answers are appearing now. Okay, that is the end of today's video on the properties of solids, liquids, and gases. I hope you found the video useful, and I hope that you managed to answer the questions successfully and get some good solid revision done. And I'll see you in the next video.